and welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe our channel, really helps the channel to grow. In this video I will discuss past paper of Introduction to AS level Organic Chemistry on public demand from 2015 till 2022 past paper. So this is first chapter of the organic chemistry. So let's start. Formula, function groups and the naming of organic compounds. This is question number 1 of this topic, that is from June 21, question paper 1 and question number 23. Limonene is hydrocarbon found in the ring of citrus fruits, rind of citrus fruit. This is limonene structure. And what is the molecular formula of limonene? You know that how to identify or how to predict the molecular formula of the given compound. So let's start. This is carbon, this is CH2, this is 1 2 3 CH, and this is CH 1 2 3 4. This is only one carbon, and over here CH3, and this is CH2, and this is also CH3. This is 1 2 3 1 2 3 and CH, and 1 2 3 4 carbon, over here CH2, in this CH2. So calculate the number of count the number of carbon atom. 1 2 3, this is 1, this is 2 3 4 5 6 7 8 9 and 10. So carbon is 10, and afterwards count the number of hydrogen atom. 2 3 5 6 2 8 and 2 10 and 11 and 2 13 and 3 16. C10 H16. So C is the best option. For which hydrocarbon are the molecular and empirical formula the same? Butane, the molecular formula is C4H10, and the empirical formula is 2 to the 4, 2 5 the 10. So this is C2H5, and ethane C2H6. Empirical formula is CH3. Pent1ene C5H10. So this is CH2, and this is propane C3H8, and the empirical formula is also C3H8. So the D option is correct option. Next question is the skeletal formula of compound X is shown. What is the molecular formula of compound X? This is CH2, this is C123 CH, this is C1 2 3 and 4, and this is CH3 CH2 CH2, and this is CH1 2 C CH3, and this is CH3. Now count the number of carbon atom. 1 2 3 4 5 6 7 8 9 and 10. C10 3 6 7 2 9 9 to 11 and 3 14 14 and 1 16, 14 and 115. This is 16 and this is 18. C10H18 and only one oxygen atom. So A option is correct option. Which compound has the molecular formula C6H10O? Similarly, we count the number of carbon atom as we have done earlier. So A option is correct option because the formula of C6H10O for this compound is C6H10O. The diagram shows the skeletal formula of compound Y. What is the empirical formula of Y? And empirical first, this is the molecular formula. Y similarly, by counting the number of carbon atom, by counting the number of hydrogen and oxygen atom. So this is 1, 2, 3, 4 and C4, H4 1, 2, 3 and 4, H4 and oxygen 1, 2, 3 and 4. So this is 1, 4 1 the 4, 4 is, and the molecular empirical formula is CHO. So A option is correct option. The diagram shows the skeletal formula of phenazine, and what is the empirical formula? The same as I have done earlier. So count the number of carbon atom first, actual number of carbon atom, actual number of hydrogen atom and actual number of nitrogen atom present in this compound. So carbon is 12, hydrogen is 8 and nitrogen is 2. So he asked you that what is the empirical formula of phenazine. So you know that 2 1s are 2, 2 4s are 8, 2 6s are 12. So this is C6H4N. So A option is correct option. This is molecular formula and this is empirical formula by simplifying. Which compound reacts to 4-dinitrophenyl hydrazine reagent but does not react with toluenes? We know that 2,4-dinitrophenyl, this is the test of carbonyl compounds, whether it is aldehyde, both carbonyl compounds mean aldehydes and ketones. So but does not react with toluenes reagent, and we know that toluene reagent does not, toluene and failing solution does not react with ketones but gives positive test with aldehyde. So he asks you that which compound react with 2,4-dinitrophenyl hydrazine reagent but does not react with toluene reagent. It means that compound should contain ketone but which does not react with toluene reagent. So this is ketone and carboxylic acid. So this is the best option as ketone does not react with toluene reagent but react with 2,4-dinitrophenyl hydrazine. But this is the compound carboxylic acid and two function group are there for carboxylic acid and ketone. So ketone gives positive test with 2,4-dinitrophenyl hydrazine but does not react with toluene reagent. So this is the best option. Here is the aldehyde and alcohol group, two functional group aldehyde and alcohol. Aldehyde gives positive test with toluene reagent as well as with 2,4-dinitrophenyl. So it is incorrect. So this is ketone and phenyl aldehyde. This is aldehyde and ketone, both groups are both carbonyl, both gives positive test with 2,4-dinitrophenyl hydrazine but does not react with toluene reagent. It does react with aldehyde, does react with toluene reagent. So over here alcohol, so does not give positive test with 2,4-dinitrophenyl hydrazine as well as with toluene reagent. So that's why A option is correct option. Which compound has boiling point that is influenced by hydrogen bonding? Hydrogen bonding, aldehyde, this is aldehyde does not have hydrogen bonding because hydrogen is directly linked with carbon, not with oxygen. This is also ketone, does not influenced by hydrogen bonding. This is ester, does not influence by hydrogen bonding because this is the compound carbon and carbon. So, last is D option is correct option, and this is methanoic acid, and it influenced the boiling point, that is influenced by hydrogen bonding because oxygen is directly linked with the H atom. So, that is why it is influenced by hydrogen bonding. Next question is the diagram shows the skeletal formula of citric acid. What is the molecular formula of the citric acid? This is very simple by counting the number of, first identify that how many elements are there. So, in this compound carbon, hydrogen and oxygen are present. First count the number of carbon atom like this, and then hydrogen atom, and then oxygen atom. So, we have 6 carbon atom in this compound, 8 hydrogen atom in this compound, and 7 oxygen atoms. So, what is the molecular formula? C6H8O7. So, A option is best option. So, let us count 1, 2, 3, 4, 5, 6 carbon atom, hydrogen 1, 2, 3, 4, 1, 3, 4, 4, 4, 4, 5, 7 and 8, and oxygen atom 1, 2, 3, 4, 5, 6 and 7. So, A option is correct option. The compound rotundone is responsible for the peppery smell of pepper and is also found in some red wines. How many hydrogen atoms are in one molecule of rotundone? So, let us calculate count the number of hydrogen atom over here. CH3, CH3, CH2, 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 CH 1, 2, 3, 4, CH3, C 1, 2, 3, 4, 1, 2, 3, 4, carbon over here CH2 and CH and CH3. So, let us count the number of hydrogen atom 2, 3, 5, 5 or 2, 7, 7, 6, 8, 8 to 10, 10 and 13, 14, 16, 16, 3 and 1 4, 20 and 22. So, 22 number of hydrogen atom present in this compound. Terpinine 4-ol is one of the active ingredients in tea tree oil. What is the molecular formula of terpinine 4-ol? So, this is the way which I have discussed earlier. Count the number of carbon atom and count the number of hydrogen atom, and we have C10H18O. Look here, this is CH3 because carbon is connected to this and 3 hydrogen atom is bonded with this carbon atom. Over here, look at here, carbon, one bond is here, one bond is here, and H placed over here. There is another bond with hydrogen. So, carbon is surrounded by 4 bonds. So, this is carbon only because 1, 2, 3 and 4 already bonded with 4 carbon atoms. So, this is CH2 because 1 and 2 bond and 2 with hydrogen bond. This is 1, 2, 3 with hydrogen bond. This carbon is only single carbon 1, 2, 3, 4 already surrounded by 4 carbon atom, and 1 double bond is here. So, similarly work out like this if you ask to calculate to find out the molecular formula of the skeletal formula. So, first draw carbon like this, number of hydrogen atom, number of carbon. So, and count the number of carbon, hydrogen and oxygen. So, C10H18O. So, this is the D is the best option. Hexamine is a crystalline solid used as a fuel in portable stoves. The diagram shows its skeletal structure. What is the empirical? First, count the number of carbon, hydrogen and nitrogen atom, actual number of carbon and hydrogen. Then work out the empirical formula by simple multiplication of these numbers. So, this is 3, 6 and 2. So, this is a simple whole ratio between these 3 elements, carbon 3 atoms, 6 hydrogen and hydrogen 2 atoms. So, first count the number of carbon atom 1, 2, 3, 4, 5, 6. 6 is carbon and hydrogen 2, 4, 6, 8, 10 and 12, and nitrogen at 4, 1, 2, 3, 4. So, what is the skeletal formula of 2-methyl pentane 1-ol? 2-methyl pentane 1-ol. Look at here, this is pentane 1, 2, 3, 4, 5 and 1 is ol and at 2 is meth, CH3. So, this is OH at 1 number of carbon atom and CH3 at 2 number of carbon atoms. So, this is the skeletal formula 1, 2, 3, 4, 5 and here OH is attached with this first carbon atom and then CH3 is attached with second carbon atom. So, A is the best option. So, this is not correct because 1, 2, 3, 4 hydrocarbon atom. So, he asked to pentane 1, 2, 3, 4. So, this is again 4 carbon 1, 2, 3, 4, 5. One CH3, CH3. So, this is not this is 1-ol, but 1, 2, 3, 4 and 4-methyl. So, this structure is 2-methyl pentane, not 2-methyl, 4-methyl, sorry, 4-methyl pentane 1-ol. The next topic is characteristic of organic reaction. This is incomplete question, so that is why start from here. What is true of every nucleophile? It attacks a double bond. No, nucleophile itself can be double bond, but it attacks a double bond, not correct. It donates a lone pair of electrons. So, it gives lone pair of electrons to the other atom, so that is why it is correct. It is a single atom, no, not it is a single atom, it is sometimes negatively charged, act as a nucleophile, but it is correct in all cases because C2H4 is also act as a nucleophile, but it does not it is not a negatively charged, it is alkene, carbon to carbon double bond. So, that is why it donates a lone pair of electrons. So, this is the best option in case of nucleophile. Next question, which organic reaction is an example of nucleophilic substitution? CH3 CH2Br NaOH CH2 CH2. So, this is not the case because when haloalkane convert into alkene, so the condition is sodium hydroxide in ethanolic medium. So, that is why this is not correct, the products are not correct. So, this is haloalkane and this is nucleophilic substitution to form alcohol in aqueous medium. This is in aqueous medium and form CH3 CH2OH and NaBr is formed. So, this is correct option. CH2, this is alkene and this is HCl. So, Which organic is an example of nucleophilic substitution? So this is addition reaction. This is, you can say, electrophilic addition. This is electrophilic addition, not nucleophilic substitution. And this is free radical substitution. Free radical substitution. The next topic, 13.3 topic of organic chemistry is shapes of organic molecules, sigma and pi bonds. Which row is correct? 3 compounds each with 4 carbon atoms per molecule. Which row is correct? Lowest boiling point, highest boiling point. This is carboxylic acid. This is ester. And this is salt of carboxylic acid. Sodium 1, 2, 3, 4, sodium butanoate. So why has ester has, because this is volatile, ester has lowest boiling point, then X has the highest due to presence of hydrogen bonding, and in this case, because this is a salt of carboxylic acid, ionic salt, so ionic compounds have high melting and boiling point. So Z, this is Z, the highest boiling point is Z, so B option is correct option. The structural formula of allene is shown. This is X, Y and Z. X carbon is surrounded, so that 3 atoms are surrounded this carbon. So this carbon is surrounded by 3 other atoms. So when 3 other atoms, that is the X is trigonal, and trigonal is 120 degree, and Y is also surrounded by 3 other atoms. This carbon is also surrounded by 3 other atoms. This carbon and this hydrogen, also trigonal, planar and 120 degree. And this carbon is surrounded by 4 other atoms, hydrogen, carbon, nitrogen and carbon. So this is tetrahedral, shape is tetrahedral, and angle is 109 degree. So that is why C option is correct option, because X is 120, Y is 120 and Z has 109 degree. So next question is which row is correct? Ammonia molecule is pyramidal. Yes, ammonia molecule there is a lone pair and form pyramid. So and 3 is surrounded by 3 hydrogen atoms. So this is trigonal pyramidal. The shape is trigonal pyramidal. So these 2 options can be correct. Ammonium ion is regular tetrahedral. So ammonium ions are formed like this, 4 hydrogen atoms. This nitrogen is surrounded by 4 hydrogen atoms. This hydrogen form dative bond with nitrogen with the lone pair of this nitrogen atom. So this is also regular tetrahedral. And ammonia molecule, all bonds are sigma bond, because single bond is a sigma bond, head to head overlap. So all nitrogen is surrounded by 3 hydrogen atoms with sigma bonds. Ammonium ion also has sigma bonds, single bond also has a sigma bond. If double bond is there, then there is a pi bond. Next question is the diagram shows the structure of compound Q. This is a structure of, look here girls, this is the structure of compound Q, and 2 of the rings X and Y contain a carbon to carbon double bond. Which row is correct? So, number of ester, we have to find out the number of ester groups in one molecule of Q, and description of rings X and Y. Okay. Description of rings: carbon to carbon double bond, in this ring double bond, in this ring no double bond, this oxygen form, this carbon form double bond. So, this is ester group, C double bond O and O, and this is also ester group. Two ester groups are present in this compound. And description of rings X and Y. X and Y, because this is sp2 hybridization, this is also sp2, this is also sp2. So, all carbon atoms lie with sp2 hybridization. When sp2 hybridization in the ring, then the ring is trigonal planar. This is also sp2, sp2, sp2. So that is why both are planar. Description of ring X and Y, both are planar, and number of ester groups in one molecule of Q is 2. So, C option is correct option. The structure of compound A is shown. Some of the carbon atoms in compound A have a tetrahedral arrangement of bonds. Some of carbon atoms in a compound A have a trigonal planar arrangement of bonds. How many carbon atoms are there of each type? Okay, tetrahedral, you know that this is tetrahedral, this is trigonal, this is trigonal, this is tetra, this is tri, this is tri, 1, 2, 3, this is also tri, 1, 2, 3, this is also tri, 1, 2, 3, this is also tri, this is linear, and 1, 1, 2, 3, this is also tri, this is tetra, this is tetra, this is also tetra, this is tetra, and this is tetra, 1, 2, 3, this is tetra, this is trigonal. Tri, I circle tri with this pen, this is tri, this is tri, this is tri, this is tetra, this is tetra, this is tetra, this is tetra. One, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 tetra, 8, and no, this is tri 8, and tetra 1, 1, 2, 3, 4, 5, 6, 7, 8. So, this is also 8. So, B option is correct option. Histidine is an amino acid. What are approximate bond angles 1, 2 and 3? So, 1, 2 and 3. This carbon is surrounded by 3 corners. This has 3 corners, 3 number of carbon atoms. So, this is 120, 2 is also 120, 2 is not 120, 2 is 107 because nitrogen is here and lone pair is here. This is trigonal pyramidal. So, this is 107 and 3 is 109.5. So, 1 is 120, 2 is 107 and 3 is 109.5. So, 1 is trigonal planar, 2 is trigonal pyramidal and 3 is tetrahedral. Next question is 4 compounds are shown C2H4, C2H5OH, CH3CHO. This is alkene, structure is this is ethanol, structure is this is aldehyde, this is the structure and this is ethanoic acid. How many of these compounds have an odd number of sigma bond? Odd number of sigma bond. This is 1 and this is also 1, sigma bond. 1, 2, 3, 4, 5, 6, 7, this is 7 and 1, 2, 3, 4, this is not odd number and 1, 2, 3, 4, 5, this is odd number, 1, 2, 3, 4, 5, 6, this is 6, this is not odd number, this is even number. So, there are 2 compounds which have odd number of sigma bonds. So, B option is correct option. Structural isomerism and stereoisomerism. We know that there are 2 types of stereoisomerism, cis-trans and optical. And cis-trans optical has chiral carbon which is surrounded by 4 different groups, and cis-trans carbon to carbon double bond, and each double bonded carbon has 2 different groups like this and this. So, that is why stereo. And structural isomerism which contain branch, unbranch, functional group isomers and position isomers also there. How many isomers with C5H10 have structures that involve pi bonding? Okay. This is 1 isomers 1, 2, 3, 4, 5 and this is double bond pent1-ene and this is pent2-ene and this is cis and this is trans. Third isomer, fourth isomers. So, this is 1, 2, 3, 4, 5, 1, 2. Pent2-ene and pent2-ene has one is this structure and other is cis-trans isomer. So, next 5 is this is structural branch isomer and this is also branch isomer. C 1, 2, 3, 4 and this is 6 type of isomers. So, how many isomers with formula C5H10 have structural involved pi bonding? So, there are total 6 isomers are there. The diagram shows molecule that sigma bond and pi bond. How many sigma bonds are present in this molecule? So, here look at here 2 hydrogen atom, this is also hydrogen atom. So, in this way you can easily calculate the number of pi bond, fully displayed structure. Okay. So, sigma count the number of sigma bond 1, there were count the number of single bond 1, 2 and over here 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. How it is possible? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 CH2, sorry, this is not, this is only CH. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So 18 are double bond, sigma bond. The characteristic smell of garlic is due to allene, X, Y and Z. So what are the approximate bond angles X, Y and Z in the molecule of allene? So this is X 120 because it is trigonal planar. Trigonal planar always have 120 degree angle, and this is also trigonal planar. This is also 120. This is 120, and this is tetrahedral 1 2 3 4, or this is 109. So C option is correct option. Histamine is produced in the body to help fight infection. Its shape allows it to fit into receptors. Trigonal pyramidal. This is X, this is Y, this is Z. X, nitrogen is surrounded by 3, so it means it is nitrogen because nitrogen has one lone pair, so it is trigonal pyramidal. And this is Y because carbon is surrounded by 4 other atom, so it is tetrahedral and 109 angle. And Z is trigonal 1 2 3, trigonal planar, so this is 120 angle. Smallest bond angle to largest bond angle. Smallest is X 107 and then Y and then Z. So X, Y and Z. A option is correct option. Compound Q contains 3 double bonds per molecules. Which bond X or Y will be ruptured by hot concentrated acidified potassium manganate, and how many lone pairs of electrons are present in one molecule of Q? So X will be ruptured because carbon to carbon double bond alkene is also oxidized by heating hot concentrated acidified potassium manganate as well as with cold dilute acidified potassium manganate. But when hot acidified potassium manganate, this C carbon form carboxylic acid and this CH2 break down into carbon dioxide and water. So this is ruptured by hot acidified potassium manganate, and oxygen has two lone pairs over here and 2 lone pair with this oxygen atom, and 2 lone pair with this oxygen atom. Number of lone pairs 1 2 3 4 5 and 6, 2 lone pair with this oxygen atom. So B option is correct because X is ruptured and 6 number of lone pairs. Isomerism, structural and stereoisomerism. In this question, alkenes and cyclic alkanes should be considered. How many structural isomers of C4H8 are there? So these are the 5. C4H8 contain 5. So we have discussed earlier with the carbon 5 pentene. So pentene has 6 isomers So this is C4H8. So look at here, C4H8 maximum has 5 isomers are there. Please keep it in mind. If C4H8 there are 5 is C5, there are 6 number of isomers, and if carbon is 6 then there are possibility of 7 to 8. Okay, this is one isomer, cyclobutane. This is cyclobutane, and this is also isomer of C4H8, two hydrogen atom, and you know that molecular formula should be same and structural formula should be different. So this is also C4H8. One is this, and this is one but1-ene, this is but2-ene, and this is 2-methyl-pent1-ene, 2-methyl-pent1-ene, or this is but2-ene has but2-ene, and this is methyl cyclopropane, 2, 4, 5 and 3, 8, methyl cyclopropane. So there are how many structural isomers? Only structural isomers, not stereoisomers. If stereoisomers, there are possibility of 2 isomers in this cis and trans, and then there will be more than 5. Okay. So but he asked you to identify structural isomers. So there are 5 structural isomers in this case. What is the least number of carbon atoms in non-cyclic alkane molecule that has a chiral centers? Least number of carbon atom in a non-cyclic alkane molecule that has a chiral center. Least number of carbon atoms in cyclic alkane. So this is 7, 1, 2, 3, 4 non-cyclic alkane molecule that has a chiral carbon. Only one chiral carbon is there. 1, 2, 3, 4, 5, 6, 7. So 7 carbon atom has a chiral center, one chiral center. The structure of citric acid and isocitric acid are shown. How many chiral centers does each acid possess? So this is not chiral because this is surrounded by 2 same hydrogen atom, and this is chiral atom because one carbon is here, and this is OH, and then CO2H, and over here H, and this is surrounded by this compound. So this is chiral carbon, and this is also middle one is the chiral carbon, and this is also chiral carbon because H is over here, OH is over here, and this is fourth. This is 1, 2, 3 and 4, 3, and this is 4. So this is also chiral carbon. Citric acid has one chiral center because chiral carbon is that chiral carbon which is surrounded by 4 different groups. So if we see this compound CH, CO2H, and this is another CO2H, and this carbon is also chiral because hydrogen over here, OH over here, and CO2H. So this is chiral for this compound, this is chiral for this compound, and this is CH2, CO2H. This is not chiral, this is chiral because this is surrounded by this, and CH2, CO2H, OH and CO2H. So 1, 2, 3 and 4. So this is only one chiral carbon and this has two chiral carbon. Citric acid has one chiral carbon and isocitric acid has two chiral carbon. So B option is correct option. Which compound could show both cis-trans isomerism and optical isomerism? B option is correct because this is chiral carbon. Carbon is surrounded by this group. This is one group, this is another, H and Cl. This is not chiral, correct, because this carbon atom is not surrounded by same two atoms over here. This is chiral carbon but not stereoisomer because this carbon is surrounded by same atom. So that's why this is also incorrect. So this is incorrect. Now look here, this carbon is also has, this compound also has a chiral carbon. This is chiral carbon but this is not C to C, this double bonded carbon surrounded by two same atom. So that's why this is also not correct. B option is correct option. Compound P is treated with an excess of hydrogen gas in the presence of a nickel catalyst. The product Q is fully saturated. This is with an excess of hydrogen gas in the presence of nickel catalyst. The product Q is fully saturated. What is the number of chiral carbon atoms in the product of Q? So look at here, two hydrogen atoms are there, two hydrogen atoms. So when two hydrogen atoms, this bond is going to break down and hydrogen over here, 1, 2, 3, and this is also has hydrogen atom. C1, 2, 3, 4, and this is also one hydrogen atom. This is also going to break down and this is also contain 1, 2, 3. This is carbon surrounded by hydrogen atom and this is carbon 1, 2, 3 and hydrogen is there. So how many chiral center are there? Chiral center 1, 2, this is not chiral center. This is also going to break down. It's also going to break down. This is carbon, hydrogen over here, hydrogen over here, and this is carbon 1, 2 and hydrogen over here. This is one chiral carbon, one chiral, because this carbon is surrounded by H and this is CH3 and this is also different group. This carbon is also, this is also chiral carbon because 4 different groups. This is CH and this all and this CH2 and this is CH3. So this is also chiral carbon. So this carbon, no, this is CH2, not chiral carbon. This is chiral carbon and 1, 2, this is CH, this is CH2, this is CH2. So this is not chiral carbon, this is chiral carbon. This is chiral carbon. 1, 2, 3, 4 and 5. This is not chiral carbon. This is also not chiral. This is also not chiral. So 5 chiral carbon are there, atoms in the product Q. Which compound shows stereoisomerism? Stereoisomerism. 2-chloropropane 1-ol, 2-methylbutane, butene, 2-methylbutene. This is not cis, showing cis trans, not chiral carbon, because this carbon, double bonded carbon surrounded by same group. So this is incorrect. 2-chloropropane 1-ol. This is 2-chloro. This is the structure of so this is incorrect, and look at here, 2-chloropropane 1-ol. This is chloro, H, CH2 and this CH3. So this is chiral carbon. This carbon is surrounded by 4 different groups, and this compound shows stereoisomers. So difluorochlorobromoethane, dichloromethane, dichloroCl, Cl, bromo H. So this is not chiral carbon, and pent-1-ene is also not chiral carbon. 1, 2, 3, 4, 5. This is also not stereoisomer, because this double bonded carbon is surrounded by 2 hydrogen atoms. Same. The formula of hydrocortisone acetate is shown. So which row is correct? Number of carbon atom in one molecule of this compound. So number of carbon atom, I have counted that there is 23. You can check by counting this, like, so you have done so many questions like this, so that's why you can check this, confirm this question by counting the number of carbon atoms and number of chiral atoms in one molecules. So number of chiral carbon atom would be 4. Look at here, this is chiral carbon, 1, 2, 3. This is chiral carbon. This is chiral carbon, 1, 2, H, CH2. This is chiral carbon. This is chiral carbon, and this is also chiral carbon, because see, this is different, this is different, and this is also different, H. This is also chiral carbon atom. So total chiral carbon atoms are 7. 1, 2, 3, 4. So this is not chiral. This is chiral. This is chiral, and this is chiral. 1, 2, 3, 4, 5, 6, and 7. So 7 number of chiral carbon atoms, and 6 is 4. So which pair of compounds are functional group isomer of each other? Butane 1-ol and butanol. So this is not butane 1-ol and butanol, this is aldehyde and this is alcohol. Alcohol and aldehyde are not isomers of each other, so this is incorrect. Ethyl propanoate and pantanoic acids, yes. Pantanoic acids, ethyl propanoate. This is ethyl propanoate, CH3, C double bond O, sorry, CH2, C double bond O, O, and ethyl propanoate, CH2, CH3, and pantanoic acid, CH3, CH2, CH2, CH2 and COH. So these two compounds are isomers of each other because carboxylic acid and esters are isomer of each other. So here 1, 2, 3, 4, 5 carbon atom, 1, 2, 3, 4, 5 carbon atom. So that's why this compound ethyl propanoate and pentanoic acid are isomers of each other. So B option is correct option. Question number next question, structural isomerism and stereoisomerism should be considered when answering this question. How many non-cyclic isomers have the molecular formula C5H10? Non-cyclic isomers. Structural can be, stereoisomers should be considered. So look at here, I have drawn these different isomers. So 6 isomers, it constitutes 6 isomers. So one is the pent1-ene, 1, 2, 3, 4, 5, and second is pent2-ene, and this is methyl 2-methyl but2-ene. So this is third isomers. This is fourth isomers, that is trans 1, 2, 3, 4, 2-but pentene. This is fourth isomer, and this is trans, and this is cis isomer. So 4 and 5, and this is 6 isomer. One, two, three. Pent 1, 2, 3. 2,2-dimethyl prop1-ene. The name is 2,2-dimethyl prop2-ene. So 6 one is this. So 6 possibilities are there. So D option is correct option. Which statement is correct? 2,2-dimethyl propanoic acid is an isomer of propyl methanoate. 2,2-dimethyl propanoic acid. This is propyl methanoate. 4 carbon is here, and this is propanoic acid. This is incorrect because in here 5 carbon atom, over here 4 carbon atom. Even though it is ester and carboxylic acid, but the number of carbon atom 2,2-dimethyl. 2 carbon over here, 3 carbon over here. So total number of carbon atom in this compound is 5. And propyl methanoate. Propyl has 3 carbon, methanoate has 1 carbon, total 4 carbon in this compound. So this is not isomer of each other. 2-methyl butane 2-ol is an isomer of hexane 3-ol. 2-methyl butane 2-ol. All and 2-methyl 1, 2, 3, 4, 5. This is 5 carbon compound and hexane 3-ol 6 carbon. 1, 2, 3, 4, 5, 6 and 3-ol. This is 3-ol, so it is not isomer. This is also incorrect. 3-methyl butane 2-on. 3-methyl butane 4 carbon, 3-methyl but2-on. This is but2-on and 3-methyl. Isomer of pentanol. Yes, aldehyde and ketones are isomer of each other. So pentanol is 5 carbon compound. 1, 2, 3, 4, 5. So pentanol is 5 carbon and this is also 5 carbon, and this is the isomer of each other. So C option is correct option. The structure Q is shown. How many chiral centers are present in the molecule of Q? So look at here. Look at here where carbon is surrounded by 3 carbon atom, 3 sides. So it means that is chiral carbon, because C over here, H over here, this is whole compound CH2OH, and this side also consider all this side. So that's why this is CH. So this is chiral carbon. This is also surrounded by 4 different atoms. This carbon is also surrounded by 1, 2, 3 and H. This is surrounded by 4 different atoms. This is also 1, 2, 3 and 4. So this is also chiral carbon. This is carbon over here, 1 hydrogen, and 1 this side, 1 this side and 1 this side. This is also chiral carbon because this is surrounded by this CH2, this is hydrogen, and this is another different carbon atom, different functional group. This is also functional group different. This is 1 carbon, this is CH3, different groups. This is also different group, and this side also different. So that's why this is also chiral. So in this way we have 1, 2, 3, 4, 5, 6 and 7 chiral. So how many chiral centers are present in the molecule of Qs? 7 chiral centers are there. The structure of damascene is shown. So including damascene, how many stereoisomers exist with the structural isomers? Okay. Stereoisomers, how many stereoisomers? Stereoisomers, double bond, this is different and this is different. CH3 and CH, this is different. How many stereoisomers? So this is 1 and 2 stereoisomers. This is the same CH3, and this is also different. This is 1 and this is 2. This is, look at here, carbon, carbon, and 1, 2, 1 and 2. So one compound, one chiral is this stereoisomer, another is this. So there are 2 stereoisomers, including how many stereoisomers exist with this structural formula. How many isomeric esters have the molecular formula? C4 isomeric esters have the formula C4H8O2. 4 isomeric esters with C4H8 like this. One, two, three. One, two, three. This is methyl. So I have drawn earlier this compound. This is methyl propanoate. This is ethyl ethanoate. This is propyl methanoate. So this is another compound, butanoic acid. So 4, 1, 2, 3 and 4. So you can draw hydrogen over here. Okay, hydrogen understood. This is hydrogen, 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 hydrogen. So carbon is surrounded by 4 bonds with hydrogen if not other element is present. Hydrogen, hydrogen. So in this way we have 4 isomeric esters. Molecular formula of C4H8O2. I think so 3 could be possible. Propyl, methyl propanoate, this is ethyl ethanoate, this is propyl methanoate, methyl ethyl propyl, methyl propanoate, ethyl ethanoate and propyl methanoate.